So we're the bad apples together, and we're presenting BroBots right here. So me and Mike, we're bros. We like hanging out, but sometimes, when with all the snow in the way, we want to hang out and do a collaboration, sort of like Halo, right? So you have your co-op online, but we wanted something more like interactive, and we both got leap motion devices. What a crazy happenstance for that happening. So we said, why don't we get together this weekend, and we can make a robot where we'll send this leap motion data over the power of the internet, and we'll be able to control this guy wirelessly wherever he may be connected to the internet. So you'll see here we've got one laptop stationed here. We got our leap motion, and I'm actually signed in. I'm the gripper, so I'll be controlling the gripper today for every task we have for picking something up. We also have a Google Hangout live chat here, which we found to be the lowest latency for video feeds on the internet. And so, so now we have. Right here, you can see I can get my boots in the way, and so when I'm doing my gripper, I can say, all right, I will pick up something down here. Mike over here, he has got another setup. He's the driver, so he's got the same setup as me. And on the board right here, this robot has a beagle bone, and this does all the pulse width modulation for driving the motors and for driving the servos for the gripper arm. We've got some fancy underglow. You'll see with the electroluminescent wire. Yeah, we hooked it up to the internet using a Belkin wireless USB right there. And so right now we're actually jacked into the wall right there. We're having a little bit of problems with the internet a little while ago, but now the laptop is our router, so it's shooting us all the internets we need. So Mike, you want to start it off? Let's drive us around. All right, so once I move my hand up, you'll notice that the arm goes down, and then the gripper on the front, that responds to my right hand. So left hand for up and down.
He's driving and you're controlling the gripper?
Yeah,
so you are doing one.
If I stop, you can go ahead. Yeah, I can do all the gripping needs I need.
And once I find my hand back in there, move it out. Turn it.
So does the leapfrog give you XY? I mean, what is it? It's a mouse emulator on the computer?
3D gestures, so you can detect fingers as well as palm positions.
And you can do roll, pitch, and yaw. So Mike actually, for his control, his left hand controls how much duty cycle we have for the motors, and his right hand actually does the direction. So we have a 90-degree cone at the front for a turning degree. So we map from this angle to this angle on your hand for that. And so, do you want to go into the back end, the node server?
So basically, what's happening is we have a node server set up with WebSockets using Socket.io. And so he's connected on one end to a route that's serving the data for the gripper, and then on my end, I'm connected to another route that's serving the data for the driver. And then the BeagleBone actually is running sockets as well using Python. And so what happens is we're both sending the data at the same time, and it's getting put together in a server, sent down to the BeagleBone. The BeagleBone is handling the rest, sort of adjusting the servos as well as the motors.
We found it really nice working with Python on the BeagleBone. That was nice to have a scripting language after a night working with a microcontroller flashing all the time. So, yeah.
So it's doing two-dimensional though. You were not doing three-dimensional. It's X.
Yeah, we can do three-dimensional if you want it, but we just map.
two.
Yeah,
Right?
just map. You guys want to give it a try?
Yeah, I'll try. Yeah. Let me try the gripper first.
Yeah. So for this one,
Yeah.
your left hand is going to be controlling. When you go up, you gotta have actually both hands.
Okay.
That's our check to make sure we're not getting anything weird.
Got it.
So yeah, we've got some filtering. So yeah, and then for your right hand, you gotta make sure. Sometimes if you get a little too close, it doesn't recognize it. But yeah, so that'll control your gripper.
So okay, you got some precision here.
Yeah.
Okay. You are able to open and close it?
So the left, right is.
So the right hand on this side is we're using the yaw to control the rotation. It's turning. And then my left hand is controlling the speed. So if I don't want to do it now, I'll shoot you up.
And the video is just coming from the smartphone?
Yeah.
And that's the thing, sending it to Google Hangouts or whatever?
Correct.
Does it actually pick something up?
Yeah,
So we hadn't had time to fine tune our gripper, unfortunately, but Yeah, the servers are much more very powerful. I think they're like 10 kilogram centimeters.
One server.
Two servers.
Yeah, so one for the gripper up
Oh,
top.
that okay. It's one of the bar.
Yeah.
So what was the most challenging part of the implementation?
I think so we started out, we knew we wanted to do the collaboration, but originally we didn't even have the wireless connectivity in it. We were thinking we were going to do a localized RF communication with the Mavarn that Jonathan Feeney had developed, because I was familiar with it. But that turned out to be a big pain because we wanted to send in data for the pulse width modulation between 0 and 1023. We ended up getting caught up in that last night, and it was just a huge hassle. Then I realized I have a BeagleBone. We could do this all in Python since we already have the leaf data in Python. And so that was really nice. And Mike already know how to implement a node server, so he had that up and going pretty quickly.
So I guess I'm a little confused. Where's the data integration happening? So we got
So-
on the BeagleBoard, both of you are talking to it independently, or
So there's a server. We're both talking to the server, and then the server
the server is running here?
No, the server's
running.
It's on the web. You guys can hit the website right now.
So so both of these things are talking to
On server, yeah. It's hosted on Node.js.
and it's sending one stream to this.
Yes.
Correct.
So
And that's
it's
on-
So this is just hooked into the
computer
into
itself.
the computer.
Yeah.
No hardware, no custom hardware in that path.
Yeah.
No.
Okay.
Where is server hosted?
It's on Node.js.
No, did too. Okay.